Once you are happy with the specification of your VAR model, you can go ahead to request further statistics, such as the variance decomposition result and impulse response function. In stata, there is a very convenient command to request both sets of statistics. It's called IRF, impulse response function in short, but it can give you two sets of output. So we request graph. That means plot the input response function for us. So IRF, which means report the impulse response function results. So if we press enter, a new window will be open, and that gives you the impulse response function that we discussed in our lecture. So if you go back to the window, you can also request IRF table IRF. That's impulse response function. Don't give me the graph, but give me the numbers that you used to construct those four charts. So if you submit this command line, that will give you this set of results. So you have a chart 1, 2, 3, 4. Those are the numbers to plot the line and the confidence bound. So you have a 95% lower and upper bound reported. So this is the lower and upper bound for the first charts. And you also have impulse response functions value there. And the interpretation is here. Okay, so the first one is impulse is from DC and the response is DC. So that's from DC to itself. And this one, number 3, that is impulse is dy and response DC. So number 3 is this chart or this table that's from dy to DC. So this table actually is easier to read compared with the chart. So similarly, this is impulse response function. And if you would like to perform a variance decomposition analysis, the command is impulse response function, IRF. Now let's have a look at the graph first. But this time, we would like to have the forecast error variance decomposition. So FEVV is the command to request variance decomposition results. So press enter. The system will generate graphs of variance decomposition. So that those are the same. Those are the same as the one we discussed in lecture. So if we close this one and go back to the window, now let's request the table. Have a look at the figures. IRF table FEVD. So this is the requested table behind those four charts. So you have some similar, the structure is the same, the numbers are different. So for example, the first chart is decomposition of DC's forecast error. So the first column, number 1 and number 3, those are the variance of the forecast error of DC. And about 97% of it comes from the shocks of DC, and it's less than 3% comes from the shocks from DY. So this is how to interpret the result. So by seeing the numbers, it's easier for us to see how big the difference is, although the pattern is quite obvious from the charts that we discussed before. So similarly, if we look at the variance of focus error of Y, that's panel 2 and panel 4. A large proportion comes from the shock from Y over there, so over 75%, but it's close to 25% from the shocks in C as well, which means if there is changes in values of Y, so value of C, DC, by standard deviation, it will have a very large impact on the forecasting error of C itself, and reasonably large, about 25% contribution to the forecasting error of Y. And so C's forecasting accuracy is mostly determined based on the shocks from itself within its own system. Y is kind of mixed.